we are going to add vectors. So let's start with an example. I have two vectors, A and B. Vector A is displacement of magnitude 50 meter, making angle of 30 degree above the x-axis. It is as shown in the figure. And vector B is the displacement of magnitude 70 meter, points angle of 60 degree above x-axis as shown in the figure. Okay, so this is the goal is to add these two vectors A and B. So the step first is find x and y component of vector A and B. So if you can look at this picture, this is component AY and that is the component AX. Similarly, for the vector B, this is y component by and this is x component bx. So the first step is find x and y component of vector A and B. Okay, so let's start with vector A. I use sine theta equals ay over a. So as usual, I will multiply both sides by a so that a sine theta equals ay. So ay equals a is 50 times sine 30, which gives me ay equals 25 meters. Okay. Similarly, cosine theta equals ax over a. So again, I will multiply both sides by a. So this a cancel out. So ax equals a, which is 50 times cosine 30 degree. That gives me 43.31 meter. So I found x component and y component here. Okay, I do the same step for the vector b. Okay, it making an angle. Vector b makes an angle of this angle 60 degree with x-axis. So let's do the step again. So sine theta equals by over b. So again, I multiply both sides by b. This b cancel out. So by equals b is 70 times sine 60 degree, which equals by equals 60.62 meter. Okay, so this is the y component. For the x component, cosine theta equals bx over b. So cosine angle is 60. Angle is 60. As before, I need to multiply both sides by b. So this b cancel out. So b is, in this case, is 70. 70 times cosine 60 equals bx. So bx is equals 35 meter. So I find x and y component of each vector. Okay, so the next step is find total x component and total component y. Okay, so let's start with the total x component. So total x component, I call it Rx. So Rx will be the sum of ax plus bx. Okay, so Rex equals Ax is 43.31 and Bx is 35. Okay, so let's check again. So Ax is 43.31 and Bx is this number. Okay, so if I add these two, Rex becomes 108.31 meter. So this is the total x component. Okay. Now let's find the total y component. So total y component Ry equals AY plus BY. So AY is 25, BY is 60.62. So RY equals 85, 85.62 meter. Okay, so we have both total X component and total Y component. Next step is to combine Rx and Ry. For that, I had to use the Pythagorean theorem as before. So you can look at here, our both value Rx and Ry is positive. So we can draw like this. This is my x-axis, this is my y-axis. So this is my Rx that represents number 108.31. My Ry is 85.62. So it looks like this. This is Ry. Okay, so the total resultant, total or the resultant is R. This is R. That makes an angle theta with x-axis. Okay, so here this R is the total, or in physics we also call it the resultant factor. Okay, so now according to our theorem, R squared equals Rx squared plus Ry squared. So we can write R squared equals 108.31 squared plus 85.62 squared. That gives me R equals 62.71 meter. So this R is the magnitude of resultant vector R. Okay, now let's say this angle is theta, so I can write tan theta equals Ry over Rx. So theta equals tan inverse Ry, which equals 85.62 over 108.31. That gives me theta equals 38.33 degree. So we have both magnitude of the resultant vector. This theta gives you the direction of the resultant vector. Okay, so now we can write the resultant vector R. We also call sometimes total, in simple word, total. In this case, this is the displacement. Total displacement has magnitude of 26.71 meter, and it makes an angle of 38.33 degree with x-axis. This completes the answer. Okay, so based on these steps, you can solve the examples. Example 2, this is very similar. Only difference is that here we have three vectors A, B, and C. Our goal is to find resultant, which will be R equals A plus vector B plus vector C. So you have to follow the steps that you learned in example 1. Okay, you can do the similar thing for this problem. Okay,